Alright, so Assalamualaikum and a very good afternoon for you guys. So today's session, uh, so we will continue the session for today for our lecture input on the passive design strategies. So I think you have learned a lot of things that has been shared by Puan Maimuna from IPTA before this. So a lot of information that she informed is very helpful and is very informative sharing session. I think so. All the things that she has mentioned should be you can apply all those things in your proposal later, right? So I think okay, it's quite a lot of things to be digest. So I hope you can just bear with us, okay? Because this one is for your own own benefit for your final project. All right. So I'll start the presentation. Okay. So my talk for today is the design with site response, passive design strategies. Because this one, you have already done your site analysis before this. You have managed to propose your master plan, your action plan, and now you are going to design whatever proposed building that that we require. And then how do you want to put those things in your site? All right. So we'll begin the session with, all right. So the issue now is we are always talk about the sustainability, the green building, and so on. So do you really understand what is sustainability? What is the green building? What are the eco things, and how does it relates to our proposal later? Okay. Is this what we can call as green building? Do you think this one is a green building? Or it is just an abandoned building with all the shrubs, because but we can call this as a green building, is it? Or can you call this one is as a green building? Literally, yes, right? Maybe. Okay. All right. And then how about this one? This one, they are trying to put okay, this one is by Professor Zhang Ling, built Green Mountain Villa where he can get away from all. But the problem is, it's on top of Beijing apartment block, and the people underneath aren't too happy. So if you are considering to do a green building and so on, you want to put sustainability and so on, not only you are going to focus on the green things only, but you need to know what are the preferences of the users, how to reflect to the site, and also the space that you have you are going to create later, right? Okay. So in this presentation, we will discuss the basic principles of. The first one is the passive cooling, wind and shading, solar geometry, sun versus building orientation, day lighting, indirect lighting, and material issues. So those are the things that we'll cover in this passive design strategies. Okay. Right. What is passive design? Can somebody answer my question? What is passive design? I think this topic has been covered some by Dr. Izura last week. He was talking on the passive design and active design. I think some of the lecture input has talked about this one. Can anybody answer me? I don't want Alia. Okay, Haris Nazmi. What is passive design?
Passive design, based on my opinion, is from how we implement somehow like cross ventilation.
Cross ventilation, okay? That can be that is a part of passive design. Okay? All right. So
Yep.
okay, thank you, Haris. Okay, it is an approach to building design that uses the building architecture to minimize energy consumption. It based open climatic consideration, attempts to control comfort, heating and cooling without consuming fuel and electricity. Use the orientation of the building, use of the shape of the building plan section to control airflow. Okay, so those are the things that you need to consider in designing your building later. Maximize use of free solar energy for heating and lighting, maximizes use of free ventilation for cooling, and uses of shades, natural or architectural, to control heat gain. So those are the things that you need to consider in designing a passive design strategies for your building later, right? It attempts to use natural principles in order to substantially reduce dependence on the fuel-based technologies or electricity for heating, cooling, and lighting the building. Okay, so uh, run away from the use of the fuel-based technologies and electricity in order to get the thermal comfort for our building. A green building is a building that in its design, construction, or operation reduce or eliminates negative impacts and can create positive impact on our climate and natural environment. And then in order to provide comfortable environment for the user and also to protect the environment, each building have opportunity to use passive and active system. But for today, we are going to focus on the passive system only, right? Passive strategy try to optimize and conserve the usage of potential energy around the building without converting it first to electrical energy. And otherwise, active strategy try to fulfill human requirement by using electrical or mechanical equipment. Okay, so we are trying to put to maximize the use of passive design strategies in our building. Okay, for instance, this one is the advantages of passive design. Provides indoor comfort, low maintenance, zero energy consumption, or we are trying to make it low. Okay, and then low running costs, promotes healthy environments, and to save the earth. So the intention is to save the earth. All right. Passive building require active users. So when you are talking about the passive building design, you are going to require a active user. For instance, okay, for instance, for this building passive, uh, occupants need to be educated as when to open and close windows, raise and lower shades and blinds, and control some of the non-automated means of controlling the effect of the sun and wind on the interior environment of the building. For instance, if you are talking about the size of a window, so that one is a passive design element, all right? But you still need the active participation of the user, okay? Okay, this one is how we differentiate between the passive and active design. Okay, for the first one. All right. So this one is an active design. If you can see from here, this one, it is using the minimum insulation. Okay, while for the passive design, we are using the maximum insulation. We can see from the diagram. Okay, poor solar gain. So only some of the solar or sunlight coming into the building. But for this one, for the passive design strategies, we are trying to maximize the solar gain into the building. Okay, and then for this one, uh, to modify the state of the building, create energy and comfort. For instance, for the active design, we are using the fans, air conditioner, pumps, and etc. to get the thermal comfort for that particular building. While for the passive design result, when a building is created and simply works on its own. Okay, the plan, section, material selection, and seating create energy through the building and save energy. So these are the differences between these two. Active strategies usually consist of heating and cooling system, while passive measures include building orientation, air sealing, continuous insulation, designing a building to take advantage of natural ventilation of opportunities. Okay, so the building itself works by on its own to get the best thermal comfort for the user of the building. Okay, what is thermal comfort? Can somebody tell me what is the thermal comfort? Guys, I think you have learned this one before this.
The temperature that is comfortable enough to live in.
Okay, good, Nuris. The temperature that is comfortable enough to live in. For instance, please indicate how you feel now. Do you feel hot? Or do you feel warm? Or slightly warm, or neutral, or slightly cool, or you feel cold? What
Hot.
do you feel now? Hot.
Yeah.
So what should we do?
Open the window, open the door, open the switch on the fan.
Okay, so those are the things you need to differentiate. Perhaps for instance, if you are using the fan, you are using the active strategies. Okay, but if you are going to use basically based on the placement of the window at your room, okay, it is basically passive design. Please indicate how would like to be now. For instance, you were saying that you feel hot. Okay, so you want to be cooler, okay? So the condition of mind that express satisfaction with the thermal environment and assessed by subjective evaluation. So basically, it is by your own interpretation. If you are feeling that you feel hot now, and then what are the things that you need to do in order to achieve your thermal comfort? Okay. The efficiency of the building envelope can be maximized in a number of ways. Minimize heat gain. Shading windows, walls, and roof from direct solar radiation, using lighter colored roof, using insulation, making selective or limited use of thermal mass to avoid storing daytime heat gains. Okay, so we usually, for this hot and humid climate, we need to minimize the heat gain to our building, right? And then we need to maximize the heat loss by using this air movement, cooling breeze, evaporation, reflection of radiation. So those are the things that you need to study in order to gain the maximum passive design strategies in your building. So those are the techniques that you need to use. Okay, so passive strategies, it is related to these three tier. Okay, the tiered approach to reduce energy requirements for cooling. The first one, the tier one, is on the heat avoidance. How do you want to avoid the heat from entering our building? Okay, and then the second tier is our passive cooling. How we want to add on, how we want to implement the the passive cooling elements into our building so that we achieve the thermal comfort. And then the tier three is only the mechanical cooling, the active design strategies. Okay. And then this one is the another way of using passive design strategies in our building. We are using the sharing devices. I think you have done this one during your site simulation before this on the site analysis, right? How to get the best shading devices and so on. Okay, the most effective method of cooling a building is to shade windows, walls, and roof or building from direct solar radiation. Heavily insulated walls and roof need less shading. Extend the overhang beyond the side of the window to prevent solar gain from the side, and use leaded louver shade to allow more daylight to enter while shading windows from direct sunlight. Okay, you can see various ways of proposing your windows here. For instance, if you see for this one, the first one, it is the standard horizontal overhang. You just put the overhang over here on top of the window. Okay, but if the orientation is wrong, then you still can feel the heat from the sun penetrate into your building. Okay, and then for this one is vertical louvers or fins for east and especially west facade. Okay, so they are using the louvers. If you're using the louvers, you need to know where is the best location or where is the best orientation of that particular fin. So you need to put it for east and especially for west facade, because we know that the sun, they came from east to the west, and then you need to know how the sun and the heat gain penetrate from the outer to the indoor. Okay, and then this one, substitute louvers for the solid drop edge to let in more light. Okay, for instance, they are changing this one. They are using louvers to let more light instead of using a solid overhang. Okay, and then this one is they are using the louvers in place of solid overhang for more diffuse light while still shading. Okay, so we are trying to gain the diffuse light instead of the direct light. Okay, so these are the use of louvers. So those are the things that you need to know which one is the best for your building later. Okay, okay, and then for this one, if you can see from this one, drop the edge for less projection. They have the overhang over here, and then they drop down something over here. Okay, so it is more, it can diffuse more light, right? And then this one is slope for less projection. This one is breakup and overhang for less projection. So those are all the design uh, of the windows that you can consider of. But this one is only limited for, this one is very basic types of windows. Okay, you can see all those examples of windows, how to put the overhang and so on. Other than this one is only basic things. All right. Okay, natural ventilation, effect of positive air pressure on the windward side and negative pressure suction. Designers often choose to enhance natural ventilation tall spaces called stacks in buildings. Okay, so these are the stack effect in a building. With opening near the top of stack, warm air can escape, whereas cooler air enter the building from openings near the ground. The window play a dominant role in inducing indoor ventilation due to wind forces. So they are trying to put the cross ventilation, and then it's create the stack effect. Okay, so the cool air come from the bottom of the building, and then the warmer air will go throughout the building. Okay, this one is also example of when you do your plan later, you need to know where is the best location to put all the spaces. For instance, for this one, they put the cross ventilation. So you will have one window over here and then another window over here, so that it will create the cross ventilation between the spaces. Okay. If you what happen if you put all the solid things over here? What happened to this area, guys? Or if you don't put any opening over here, what will happen?
The hot wind trap.
The hot wind trap. So the cross ventilation between for the wind is not happen. Okay, no circulation. All right. So those are the things that you need to consider during designing your plan later, right? So you need to know how you don't want to trap the hot air, and how do you want to make the cross ventilation to gain the maximum thermal comfort for your building. Okay, right. So this one is another example. I think the passive cooling in traditional Malay houses, vernacular architecture. All right. So this one is an example of Malay traditional house, where usually we will put it on the steel. Okay, so that, all right. So if you can see from here, it is still how catch wind of higher velocity. So still the wind can cross along the underneath of the house. Okay, lightweight construction using low thermal capacity material keeps house cool. Okay, the thermal mass of that particular material also is one of the consideration in achieving the passive design strategies. Okay, large roof is for effective sun shading. So this one is for sun shading, and then open interior spaces with minimal partition allow good ventilation in the house. So usually the house is very open. Usually they only have one room in each house. It is only for separation between male and female. Okay, so when the open interior spaces is more, it allow good ventilation along the entire house. Right? Fully openable windows allow ventilation at body level. Okay, so this one is the window. If you can see some of the window, they are, we call it as tingkap labu. It is a big window. Sometimes they put it in big window over here. So if somebody stand over here, they can feel the breeze from the wind. Okay, so it provide more good ventilation for the wind, right? And then ventilated roof space help to cool the house. Atap roofing of low thermal capacity give good insulation against heat. So they usually roof the atap roof and so on. And then also they have the ventilation through roof joint. And some of the houses, they have this wood carving to allow the wind to enter through the through the holes, okay, using this ornament. All right, so this one is basically example. This one is also another for an example for the Malay traditional houses. Okay, this is something which is similar from the previous one. If you can see, so those are the things that you can consider in designing your building later. I know you are going to build some new modern building with modern look, but some of the gist from these Malay traditional houses can be put in your design later. All right, okay, so this one is the summary for the Malay traditional houses. They are using the lightweight timber frame structure, timber or woven bamboo walls and screening, elevated floor, sloping long roof with large overhangs, minimize area of east-west orientation, louvered windows, doors and windows, and direct cursive wood carving. Okay, so those are the elements that are containing in Malay traditional houses that you can also consider to be imposed in your building later. All right. So this one is on the courtyard effect. Courtyard effect is also one of the passive design strategies. You can put this courtyard effect in your building later. Courtyard spaces can provide a cool semi-private interior microclimate from which to draw cool air into the building. Okay, for instance, the use of the courtyard as an architectural design element is adaptable due to its passive tendencies for low energy consumption in buildings. It has social, cultural, religious, and environmental usage, not only for passive design strategies. So they has all these elements, not only to cater on the passive design strategies only. For instance, there are a lot of the typology of the courtyard. Right, you can see from here courtyard effect. Okay, this one is the courtyard effect during the day, courtyard effect during the night. This one is typical courtyard. All right, and then the dual courtyard effect. If you have a courtyard effect, a courtyard over here and then another one over here, you can create the airflow inside the room can be maintained by dual courtyard, where courtyard is kept cool by shady trees, vegetation, and under the sun. Right. This one is courtyard effect with evaporative cooling. Reduction in temperature resulting from evaporation of a liquid, which remove the heat from the surface which evaporation take place. Right. This one is also another type of courtyard, deep courtyard house. If you can see from here, it is double volume. Okay, this one is double story. And then you have this double volume of courtyard over here. So the effect of the courtyard is there are some difference between this one, the single story courtyard. Okay, and then this one is also double courtyard house. They have the courtyard, the two courtyard over here. So these are the things which will affect the use of courtyard in this particular building. Okay. Another way of putting your building in passive design strategies is using landscaping, right? Landscape and shading devices can be used in combination to provide an area of cooling around the building. So these are the common thing. I think we saw it in a lot of green building where they put all this landscaping around the area so that they can achieve the maximum thermal comfort. Vegetation can be used to shade the building and create a cool microclimate around the building. Okay, so those are the things. If you want to propose your building with a lot of greenery later, you can put all the landscaping here, but you need to remind that it also require a lot of maintenance. So perhaps the selection of the trees and also the location of the trees. You need to consider all of those things, right? That's why we will use the expertise of landscape architects, all right? Because we want to know what is the best landscape that we need to put over there. What is the best trees? What are the trees that require less maintenance? What are the trees that only can grow in minimal growth? If it is cannot be controlled, then it will be too big, something like that. Okay. Okay, so these are the passive strategies. Who can tell me what is the first one? What is the first one? Guys? Shading device. Okay. Second? The second one?
Solar.
Solar. Okay. What is the third one? Oh, okay. The third one is the operable van in skylight. All right. How about the fourth one? What is that? Daylight, diffuse light. Open vertical circulation, create light well. Okay. You can also put a light well inside your building, allowing daylight to the interior. Okay. What about the fifth one? What is that? Ventilation. Strategic windows placement. Okay, so you need to know where is the best location of your windows and also your doors. Okay, in order to enhance the natural ventilation to help to cool the building. So if you put it in, let's say you put it in the north and south, is it sufficient? Is it really required uh, a big size of the window? Or you just put it in the east and west? So you need to consider all those things. What about the sixth? What's that? Exterior wall material, rigid insulation with an air gap. Okay, they put the insulation between the walls. The seven, shipping containers are reuse resource, so highly sustainable because they are using the container, which is they just reuse the material to be part of the building. And then the eighth is the super sufficient radiant floor heating system, provide comfortable warmth for the house. Okay. And then what about this one? Okay, this one is also some of the elements that you can put in your building later. For instance, green walls. Cool buildings make a green statement, demonstrate permaculture. Okay, they put all this greenery over here. But like I said before, you proposing this one, you need to know what is the best landscaping that you need to put in order for you to create a less maintenance building as well. Okay, this one they are using the photovoltaic panels capture sun energy. Okay, so that they can just use the solar things to light the building. Okay, and then this one they are using the store rainwater for flushing toilet and landscape irrigation. And then other features such as building envelopes and also side features, grass fibers and so on. Okay, so they are trying to maximize the strategies of passive design inside this building. Correct? Understanding solar geometry is essential in order to okay. We go through the solar geometry or sun orientation. This one is another way of achieving your passive design strategies. You need to understanding solar geometry is essential in order to do passive building design for heating and cooling, orient building properly, understand seasonal changes in the buildings and its surrounding, design shading devices, use the sun to animate our architecture. Okay. So for instance, this one is the Perimeter Institute in Waterloo uses the sun to daylight and add character to that space. Not only you can use this sunlight to penetrate into building for passive design strategies only, but you can also use it for the aesthetic value. If you can see from here, the choice of the windows itself, it creates all this shadow casting, right? So it adds the character of that particular building, right? So not only for the passive design strategies, but it is also for the aesthetic value for that particular building, right? Solar transmission through varying types of glass. Okay. Okay, if you are using the clear glass over here, so you need to know this one is already related to the material. Okay. If you are using the clear glass, the heat gain, let's say it gain more heat if compared to the heat absorbent glass, right? Most of the incident solar radiation is transmitted and re-radiated in, so the heat gain is lesser. And how about the reflective glass? If you are using the reflective glass, so most of the solar radiation is reflected, so the heat gain is the lowest. So in order for you to design your building later, you need to know what kind of materials that you are going to use, right? When you're looking to avoid heat entering the building, it is crucial to prevent it from its initial transmission through the glass. As one, the heat is in, it is in. Okay, so you need to know how do you want to reflect the heat from entering your building so that you can maximize the passive design strategies in your building. Okay. Types of radiation, you have the reflected radiation. Okay, this one is reflected the face. This one is direct radiation, and then this one is also reflected radiation from the surface to your building. So you need to know what kind of radiation that your building will gain, right? For instance, this one, London skyscraper's solar dead ray melts car. Okay, the car. Okay, if you can see from here, car with mirror panels and Jaguar badge had melted after 2 hours park because of the reflection from this building. Okay, he just parked his car in front of this building and then it melts. Right? Why? Because it is too bright that it is so bright that it's being blamed for melting everything in its path, including a few cars. The concave design and mirrored glass, due to its distinctive shape, has caused the sun to shine powerful focused rays of light into the street. Okay, if you can see from the building shape itself, because it's concave design and it is mirrored. Okay, so it melt everything along the way. So no more walkies called London skyscrapers which melt, okay, by reflecting sunset affected with shading. So they have tried to put something over here, the shading device, so that it won't melt anything after that, right? The concave shape of the skyscraper means that a large amount of sunlight reflected into the small area. If you can see from here, this is the design of the building. This effect currently lasts for around 2 hours per day and is suggested to be present for approximately 2 to 3 weeks. Okay, so that's why the light is reflected from here to here. Has been fed, and then the building has been fed with a sunshade known as bristle to prevent the glare. So after that, so they have the solution for this building. So, moral of the story, if you're designing a building, you need to know what is the long-term effect of a particular building so that you can try to avoid from trying to rectifying the mistake. Okay, right. So for this one, okay, the sun is not static. You cannot design the device to shade only at solar noon. It needs to be function during the late morning and early afternoon hours as well. Okay, for instance, if you are proposing this one, for instance, if you are you can see from here, this one is an example of a group of windows that are located together. Okay, so you need to calculate how does the overhang can shade the overall windows. Okay, for instance, for this one, they are using the louvers, so some lights are diffused. Okay, over here. And then for instance, another thing is you need to know what is the best way in providing the solution in order for you to get the minimum heat gain to your building. Okay, for instance, you are proposing this one, the single window with single overhang. It is in fact ineffective because this is the coverage of the shadow casting. All right, but how about this one? How if you are trying to lengthen the overhang, the dimension of the overhang, so it can create more shadow casting over here. All right, so it will be safer for you, right? And then how about this one? This one is also using the one single window, but the overhang is put over here, not only on the top of the window, but also on the side of the window, right? By simply extending the device either side of the window, a better degree of shading can be achieved. It is sometimes more economical to gang the windows than to provide individual windows with individual shading devices. Okay, so this one, although it is also can try to minimize the heat gain to the building, right? But it is still a only single window. How about you put it as a group of window? Okay, so it will be more economical, right? Because the overhang can shade all of these windows over here. So those are the things that you need to consider in designing your building later, right? Even the types of window, even the size of the window, and then the location of the window itself, right? That's why we ask you to do all the simulation and so on. For instance, you were doing my group were doing on the MBIP. Asha, you did the simulation, right? So because of the example of the current situation, the window is too small, so the room is too dark. Okay, so we are trying to enlarge the window size in order to gain more sunlight to the particular area. So you need to do the best location, the best size, the best design of that particular window. All right. This one uses ceramic fitted glass that is sloped to allow some light but shade rain and wet snow. Okay, because this one is in four season country, so perhaps they are sloping overhang over here so that they can also not only to shade from the rain but also from the snow. Okay, this one is also an example of how they try to get to uh, get rid of the snow. Okay, this one the difference between the solid overhang and the ventilated hot air reduce no load. Okay, this one is solid horizontal overhang, and then this one is louvered of the horizontal overhang. For instance, this one traps hot air next to the building, and also it need to cater a lot of snow load. But if they are using this ventilated hot air, so it can be more effective to cater the load of the snow. Okay. Shading strategies for east and west orientation. Okay, you need to know where is the best location that you need to, where is the best orientation for your particular building, right? So, for instance, you have this morning sun over here on the east, and then the sun will come to the west after this, right? Something like this. So, this one is better. Why? How about this one? Which one is, why this one is cannot it is not encouraged? Can somebody tell me? I think you already know about this one.
The surface area facing
Okay,
the next much larger.
the surface area is much larger. Okay, so along the way from the morning until the afternoon, right? So a lot of the surface, the large surface will receive a lot of heat from the sun along the day. Okay, but for this one, it is only minimum surface that only receive this heat from the sun. Okay. The simple overhang strategies for south-facing windows do not work for east and west facade. For instance, for this one, horizontal overhang do not work on east and west facade. Okay, so you need to put something in order for you to try to get rid of this sun penetrate into your building. Okay, because this one is the direct sunlight along the morning until the evening. Shading strategies for east and west orientation. The best solution by far is to limit using east and especially west windows, especially in hot climates, right? And then the best next solution is to have windows on the east and west facade face north or south. Okay, for this, for instance, for the first one, try to limit to the use of east and especially west windows as much as possible in hot climates. Okay, try to get rid of it by putting the orientation in the best way. Or what you can do is, if you you can use the shifting the windows to face north or south. Okay, you try to put the orientation of the window south in order to get rid of the heat gain from the sun. Okay, so those are the strategies that you can put in your building later. Okay, and then you can also use vertical fins. Spacing is an issue as well as fin length. Must be understood that if to be effective, they will severely restrict the view. Okay, they will severely restrict the view. They are, for instance, this one is using vertical fins. If you can see from here, they are using the more gap between this fin. But for this one, the solar penetration is reduced by moving fin closer together, making them deeper or both. Okay, but if you have achieved this one, the exposure and angle is achieved, but it will restrict the view. So you need to consider the best way on how to achieve the passive design, and also how to get the best view of that particular building. That one you need to consider later. Okay, it will be related to the site and then the orientation of your particular site and so on. Okay, that will be on your individual project. Living awnings. Living awnings such as trees and trellis with ones are very good shading devices. They are in phase with the thermal year, gain and lose leaf in response to the temperature changes. Okay, for instance, other living shape option, you can just plant the tree over here, and then this one is related to the four season countries. How about how if you just put the trellis next to your building? Okay, so these are the difference. How do you try to avoid the sun heat penetrate into your building? This one is using a big trees, and then this one is only using the trellis, and then this one they are only using the planter box. Okay, so those have the difference effect into your building. Choice of materials, low thermal mass, the ability of a material to absorb and store heat energy. A lot of heat energy is required to change the temperature of high density material. For instance, you are using the lightweight material, for instance, the timber, wood, processed wood, bamboo, galvanized iron, and so on. So you need to know what are the characteristics of particular material that you have chosen. Okay, you need to choose the more low thermal, the lower thermal mass for that particular material, right? And then you need to check also on the durability. For the durability, usually we use concrete and bricks. And then this one is terracotta, hardened clay, and ceramic. It is a good insulator of heat. So you need to know what is, as I said, what is the characteristic of the material that you have chosen, you have proposed, right? In order for you to achieve the maximum design strategies. For instance, this one, Okay, this one is a bamboo house. Basic design, single veranda, double veranda, extension design, and so on. So this one is a proposal on the modular housing using bamboo. Okay, so it is a good material with low thermal mass that we can also consider. But in terms of durability, perhaps the house can only maintain for 5 or 10 years. All right. So in order for for us to achieve for more long to achieve more durability, perhaps the bamboo should be treated, or it should be maintained for every 5 years, something like that. So that's why you need to know what is the characteristic of each particular material that you have chosen. It all has the pro and cons for each material. Okay. Reduce energy loops, daylighting. Okay, the tiered approach to reducing energy requirement with daylighting. The tier 1 is orientation and planning of building to allow light to reach maximum number of spaces. Tier 2 is glare, color, reflectivity, and material concern. And the third one is the efficient artificial lighting with sensors. The use of energy efficient features maximize the amount of electricity required for artificial lighting that come from renewable sources. Okay, so you need to know how to use the energy efficient features. Daylighting does not equal sunlight. Okay, daylighting is about bringing natural light into a space. Many daylight spaces do not want or need direct sunlight. Direct beam sunlight is about heating the space. So we want we want the daylight, but we don't want the heat. Okay, so that's why you need to know what are the spaces that need more daylight, and what are the spaces that can be more that only want dim light, something like that. So you need to differentiate all the spaces with its function. Okay. Differentiating passive solar heating and daylighting. Sunlight light is about free heat. Daylight is about free light. So which one do we want? We want the free light, right? The daylight, diffuse light. Okay. Daylighting is environmentally advantageous because of reduces the needs for electric lighting. So we don't want to switch on the light during the day. For instance, before this you were in your studio, right? Why did you need to switch on the why do you need to switch off the light during the day? Because the perhaps the amount of daylight penetrate into your studio is not enough, so that's why you need to use the artificial lighting. Okay, therefore reducing the energy needed to the power the light, reducing the heat generated from the light, thereby reducing the cooling required for the space. So you need to take advantage of this daylighting. Daylighting concept prefer diffuse or indirect lighting instead of direct lighting, because if you are going to focus on the direct lighting, it also bring the heat into your building. Okay, with the proper use of shading devices to block direct sun penetrate into the space, all exposures of the building can receive diffuse light rather than direct sunlight. So those are the difference between these two. Okay, you need to how to make it diffuse, or how to make it to be indirect. Okay, those are the strategies that you need to think of. It is necessary to differentiate strategies as a function of building use. Right? Okay, light is important architectural design tool. It has the ability to bring architecture to life. It relates to the use and cultural identity of the building. For instance, this one is City Center Las Vegas. If you can see the location or the design of the window itself, how do they make it more, they make it indirectly into the building, not the direct daylight. Okay, light also can be used to reveal experience. Okay, this one is the Seattle Public Library uses the contrast of light and shadow that is cast by the diagram to create an exciting experience as you head toward the entrance. Okay, like I said before this, it is not only you are going to achieve your thermal the maximum thermal comfort, but it is also about your experience, the journey into your building. Okay, for instance, for this one, it has the different types of opening. One is a very large windows over here. Okay, and then there's another one is they are using the patterns, sun shading in order to to create the shadow casting over here. Okay, so it brings the character to that particular space. Okay, and also for this one, they are also try to design some kind of this one is the glass in order for you to get the best shadow casting over here. Okay, and it create the character along the journey from here to here. Okay, you have the different feeling from the beginning until the end of this journey. So something that you can do for your building later, perhaps from the beginning of the entrance of your building, you want to create something which is more, let's say you want to create something like a sense of welcoming. So how do you want your user to feel all this sense of welcoming? So those are the things that you need to consider. You really consider. Perhaps you want them to walk from the very dim area, and then suddenly the light penetrate in, and then it become the sense of surprise, something like that. Okay, create the journey so that it will be very exciting, and then it bring the people to your building. Okay, light also can be used to reveal form. Okay, if you can see from here, this is from the Frank Gehry architect. Users like to create a play of shadow on the curved form and help to define the sculptural form. Okay, so this one is also, it is using the material in order to reveal the shapes of that particular building. So we can read the building from the shadow casting and so on. We can see the depth of this particular facade, right? So it creates the excitement. From the far, it can be seen from the far. So that's why it brings people to this building. Light also can be used to reveal space. Okay, if you can see from here, this one is also related to type of shadow casting and so on. Alright, and we have this one, it is very solid area in the middle, and then the upper layer space is designed with these patterns and so on. So it create this space. Alright, uses the extreme brightness provided by the skylight and the light colored stone material to reveal the character of that space. So that's why you need to build the character of that particular space. And then this one is also related to the function of space itself. Okay, you need to know the function of the space itself. For instance, for this one, it is the main space that you want everybody to come here, and then you feel the character of that space. All right, so perhaps this one is the main area, and then you want to put a very something like the sense of welcoming over here. Okay, light can be used to reveal meaning. The Pantene room relies on the light from 20-foot oculus to wash the interior with a gentle inspirational level of light. Okay, so they have the main light can penetrate from this one, and it reveals the meaning on the top of the interior building. Okay, and this one is also another example of the time of the day will affect the readings of the window in the building. Windows look very different on the interior and exterior during the day and night. Okay, we can see from here. This one is from the exterior. Okay, and then this one, how if you are from the interior space, we can see all this light penetrate into this one. Okay, so those are the character that we want to achieve in our building. Right, so for the summary, this one is all the summary. Using passive design, building form, and thermal performer building elements, including architectural, structural, envelope, and passive mechanical are carefully considered and optimized for interaction with the local microclimate, fully eliminate requirements for an active mechanical system, and to maintain occupant comfort at all times. So that's why we need to implement the passive design strategies in our building. Okay, even though we may not achieve the ultimate passive design division on every building, implementing the passive design approach to the fullest extent possible will lower building energy use. Okay, so you are not saying that you are required to put all those strategies in your design, but perhaps you can try to maximize it in order to gain the full benefit or advantages for your own building. Okay, building shape, orientation, and composition can improve occupant comfort by desirable site-specific energy. Through properly applied passive design principle, we can greatly reduce building energy requirements before we even consider mechanical system. So we try to put the best of effort for the passive design first before we consider using the mechanical system. Okay. Passive design can include consideration of the location, landscaping, orientation, massing, shading, material selection, thermal mass, isolation, internal layout, then the positioning of openings to allow penetrating of solar radiation, visible light, and for ventilation. So those are the things that perhaps you can use this one as your checklist later. If you're proposing your building, have you managed to at least achieve this one? Is that the best location? Okay, or is that the best orientation that you can put for your building? Okay, and how about the landscape? What kind of landscaping in order for you to shade your building? Something like that. For instance, at your current site now, they have no no shading device because it is a developing punya area, right? So how do you want to try to resolve that thing? Because you were saying that the sun directly will penetrate into the building. So how do you want to try to make it at least diffuse the light or just invite the indirect light to your building? Okay. These passive strategies are used in various countries. However, there are usually natural climatic factors that limit the use of each technique. Okay, so you need to know. Or because we are living in hot and humid climate, so which one is the best solution? For instance, if you are using the sloping overhang, is it the best way you want to put in our microclimate, something like that? Okay, passive design working with the climate, not against it. So you need to know. That's why we need to really understand our climatic factors, right? There are many surrounding factors that should be considered in order to come out with the right decision, especially in our hot and humid climate with extreme variation in rainfall. Okay, so you also need to consider the abundance of rainfall along the year for our particular climate, right? So, okay, with all that, I think that's all from me. Thank you very much. If you have any question, you can just ask here before we end our session. Okay. Thank you. Are you okay, guys? Or you are too shy? All right. Okay. I think if you don't have any more question, is ARYLI here? Okay. I think that's all from me. If there is no other question, or you can just PM me if you have any question after this. Okay. I think we will start our quick session on the afternoon session after this, perhaps 2 o'clock for everyone. I'm not sure. You need to ask your studio master. Okay. So if there is nothing to be discussed more, I think class dismiss here. Okay. So thank you very much everyone for participating.
Thank you, Doctor.
I think
Doctor.
okay.
Thank you, Doctor.
I know
Thank
there
you,
are a lot of
Doctor.
things to be digested from the IRDA and me. So try to go it carefully lah. So after this, we will upload all the presentation for you to re-watch. Okay? All right. Thank you. Bye.
Thank you, Doctor.
Thank you, Doctor.
Okay. Bye bye.